Hi guys, this is Mrs. Gessler, and in this video we're going to talk about impulse. So in our unit right now we are talking about momentum, and remember that momentum is the letter P, it's a lowercase, and it's equal to m times v. And in our last video we talked about how when we apply Newton's second law we can rewrite it as the net force is equal to the change in momentum over time. Okay, so it's the rate that momentum is changing. And those are all, well, momentum and velocity. And the force are vectors. That's a little arrow symbol there. Okay. And if we rearrange this for the change in momentum like this, we put that delta t on the other side like that. We end up with our new thing right here. This right there is called the impulse. Okay, and that's what an impulse is. The impulse is the product of the force times the time, and it tells you it changes momentum. It changes the momentum. Okay. And the letter that we use for it is usually I, but sometimes on the equation sheet they use the letter J. So you might see it I, you might also see it J, and that's totally okay. I think your book uses I. Actually, it seems to spell it out. Impulse equals F delta T. Okay. It also has a direction. And it equals change in momentum. Okay. So you can do all sorts of different equations there. When I was in high school, they taught it to us this way, m delta v, like that. And then we had to memorize it, Fat Mav. My high school mascot was the Mavs, so we were the Fat Mavs. So it was an easy equation to remember. When you're looking at this, sometimes you get information about two objects running into each other, and when they do that, the forces on them are going to be the same because remember that Newton has a third law. Newton's third law says that the force on one object due to the other is the same as the force on the second object due to the first, but in the opposite direction. Okay. And so the impulse is also going to be the same because the time, the one's not going to touch the other while it's not touching the first one. So if we throw the delta t in there, the impulse is also going to be the same on one to the other, but in the opposite direction. Okay. And so we can get, oh, I don't know if I had that high enough for you to read it there. There it is. So that we can get some information from those for collisions, which we'll talk about in a little while. When we talk about what's happening, sometimes the impulse changes. Sometimes the force changes, and so we end up with graphs of force versus time that might look like this. Okay, so and what we're looking at is the area under the curve here. In AP Physics 1, usually we look at something more like this. And so this would be what we're looking for the area of. And, or we're looking at something a little bit different. There's this thing that they call, for this one they call it a full width half maximum. So they go all the way over and then half as high. And this, presumably this rectangle here, has the same area as this whole thing, full width half maximum, okay, would be how you would find the area of this thing. I don't know if you actually have to find that, but that's how you would find this here, okay. This one knows what you're probably going to see most likely on AP questions or some other interesting shape, maybe like all the other ones that we've done where it looks like this, okay? And so you have to find the impulse based on that, and then it's just triangles plus squares, okay? And so this is the kind of questions you might have to answer here. Okay, remember, this is a good thing to remember. I think that's what it shows on the equation sheet. This is a reasonable one to remember, and knowing that the impulse is the same, it happens at the same time, and it all comes from Newton's laws. So useful. Thanks for watching. Let me know if you have any questions.